Hey Algebra 1, here are the notes for 8.4 talking about polynomials. So we recently got done talking about monomials, which are 1. Poly, the root, means many. So a polynomial is made of or sum of many roots, many monomials, made of many ones. And one important thing we need to know about polynomials is that they may not have negative exponents. So if we ever see any variables in the denominator, we know that it's not a polynomial. So if we keep going with this root idea, what does a binomial mean? Well, it means it's the sum of two monomials. A trinomial then is the sum of three monomials. All right, so let's look at these examples, and we're going to try to state whether each expression is a polynomial, and if it is not a polynomial, we're going to also say that. So 36, notice that is just one term, so that's going to be a monomial. Mono meaning one again. This one looks like it should be a binomial, right? It's made of two parts. However, it is not. Why is it not? Because this, when we flip it up to the top, is the exact same thing as 3q to the negative 2 plus 5. Remember, we can't have a negative exponent, so this is not a poly, and I'm going to shorten this to not a polynomial. Sorry, I'm off screen here. Let's see if I can zoom out. There we go. I know this is hard to see sometimes. Let's see if I can get it any better for you there. There we go. All right, so let's keep going with this. This one, notice no negative exponents, and it has three distinct terms. However, when we simplify this piece, we notice it becomes 6x plus 5. This is no longer a trinomial. This is, in fact, a binomial. It's made of two parts. So notice we have to simplify things before we can classify them. All right, let's keep going. This one has three distinct parts. None of them can be combined, so this is a trinomial. All right, this last one, if I rewrite it, I notice right away that it has a negative exponent. So even though it's made up of three parts, it has a negative exponent, which means it is not a polynomial. All right, the next thing we need to know is the degree of a monomial. So the degree of a monomial means the sum of the exponents of all of its variables. So I'm going to write that here. Sum of all exponents of all the variables. There we go. So for example here with a monomial, the highest degree we have is a 1 there, so that is a degree 1. Now let's look at the degree of a polynomial. This is the same as the degree of the monomial term with the highest degree. So it is the degree of the highest exponent. So let's look at what that means. Let's go a little further. No, I was off screen there. Sorry about that. So if we find the degree of this first polynomial, it's made up of many monomials, we notice that this is going to be the sum of each of the exponents. So here, we have to remember that this variable technically has a 1. So if I know that this is the sum of all exponents of all the variables, I know it's going to be 2 plus 3 plus 1. You cannot forget that z. So this is a 6th degree polynomial. What about this next one? Well, this one doesn't have any exponents. However, we should notice that the a, the b, and the c technically have imaginary 1s for their degree. There we go. Since each one has a 1, when I sum their degrees, I have a third degree polynomial. All right, last one here. For this polynomial, it is the highest exponent we have. So I have an 8, a 4, a 2, a 7, and a 6. So this is going to be, I have 12 total here. Here I have 3. And here I have 13. So out of all my monomials that make up this polynomial, this highest monomial term is going to be a 13th degree. This can be a little tricky, so make sure that you do a ton of practice work with this. If you need to do a few extra homework problems, I encourage you to do so. If you have any questions, please let me know.